Okay, so some recording or not? Yes. So today we are going to move from the Siman Arena blocks and elements. Today we're transitioning to another set of templates that are within Arena with the goal of understanding how this software is built and also how the original setup is connected to the new set of blocks. And you'll see that the templates that we are going to be using are not the ones that are showing up when you open the software. We'll get to those after we learn the ones that we are going to teach you today. Okay, you'll see that once you learn those, the other ones are going to make a lot of sense because the ones that you're seeing when you open the software package are basically the only difference is like they have different colors. And in some cases, some of the things that we do pretty often, like setting up the attributes, certain attributes are kind of built into some of these new blocks. Like if you want to assign the arrival time, there's a block that do that. Other than that, the templates that you will see are going to be the same. But we'll be transitioning to from Siman blocks, which are the blocks and elements, to the Arena blocks. And we don't have elements anymore. So that's the other thing that we are going to see. So this is lecture 4, lab 4 for simulation. And the other thing that we are gonna do the first time or for the first time today is to incorporate a variable within our model. Okay, so far we've been dealing with attributes, but today we're gonna work with a variable, and the variable represents some system characteristic. These are allowed to change or update values through the simulation run, like things like the cost, for example, as you process more parts. If you're looking at the manufacturing process, you know, your cost is going to be higher. So this cost is going to be increasing until the end of the simulation. And another example will be the working process, which is going to be changing constantly depending on the arrivals of the orders and the processing, and also depending on how many outputs or how many parts you have completed during your processing time. So today we're going to be adding variables to our simulations. This is something that you already know. So if you look at the slides every time we move to a new or we add some information, I'm putting a star just to, when you go back to study, you can differentiate what is new between the previous lecture and the lecture for this day. So here I'm highlighting the variable, which is the new thing from the slide. Remember to set up your work environment, which is always something that we do that in order to make sure that we save our work. And before we get into the new templates, I want to show you some history about this particular software. I always mention Siman. Siman stands for Simulation Modeling and Analysis, and that's the name of the original software before it was named Arena. This was developed by Dennis Pectin in 1982, and it was the first simulation language for the computer. It was general purpose with manufacturing capabilities, has an orientation in terms of process in which you have entities, the objects of interest moving through some of these resources. It had input and output analyzers, also an interactive debugger, and it serves as the Arena core language. So even today, if you, and I can show you how to do that, if you go behind the scenes, behind the interface, you'll see this Siman language still present in the software after more than 40 years. So it's been there for the long time. So this is what I refer to when I say the original software or the original code when you were building these simulations in the 80s, you basically were building code like this. You were defining everything in your experimental frame. So there's a difference between, yes, so maybe if I look at this one, I try to see which one is the model will be this side, and this is where you define your experiments, right? So you have two pieces, the code for the experimental frame and the code for the model. From there, we transition to these blocks, which are the ones that you have learned so far, in which you have the model frame and the experimental frame. And today we're going to transition to this. All of those three pieces are representing the same system. So this is the code for this. And now that you learn how to use this, you can do all this with just this. So that simplification is what's been happening with this particular software package, which is good for the user, but at the same time, as you gain that flexibility or that, I'll say, easiness in terms of building your models, you are also losing some of the practicality or maybe losing some of that flexibility in terms of building more logic that could be more close to the practical environment. So again, this and this and this are representing the same thing, but you can see how simple this looks now. So that's what I'm going to be teaching you today. How do you combine, or how they combine some of those blocks into a single block like this one. For example, when the create block is doing the same thing, but when you're representing a resource, now instead of using the queue, the seize, delay, the release, you only have a single block. And then you, instead of having a count block, a tally block, and so on, you only have a record block that is multi-use in a way that you can select what you want to do with that block. And then the dispose is the same thing. So let's look into these new templates. These Arena modules are selected from template panels. So for example, we have different templates, the basic process, the advanced transfer. So the template that I'm showing on the slide is representing the basic process, in which you have, well, the blocks that are the basic ones. You have the create, the dispose, the process, which is going to be representing your resources, decide, which is substituting the branch block, and then you have you're batching your entities, you're separating them. The assign block is doing the same thing as the assign block, and then the record block is doing tallies, counters, and so on. The other thing that you will observe is now you have these little modules here that looks like tables. Those are being used to define your experimental frame. So now instead of pulling blocks into the model, you're going to be using these little tables to fill out some of the information that is needed for your experimental frame. So I'll go into those in a minute. So here's some additional templates. The advanced process, these add additional logic in terms of the things that you can do with your entities. Like for example, you can use that process to represent your resource. But if you want to go back to having a seize, delay, release, block, you also have that option. And this is in terms of like one of the exercises that we did in class, in which you have the operator interacting with the machine. It allows you to build that type of logic when you have those separate blocks. And then you have additional like signal. I will talk about those later. And then the advanced transfer, this is in terms of, let's say you have some type of conveyors, or you have some type of forklifts moving around the facility, transporting some of your items. You can build that logic also using the advanced transfer module. So we'll try to get to this in one of the latest lab, talk about advanced transfer. If everything runs smoothly throughout the semester, we should be able to get there. If not, it's not that difficult to pick up. You can easily learn how to use this advanced transfer module from a book or online. But the rest of it is what's really relevant, especially for the type of systems that we are going to model. So let's start with some of the modules, how they are different. So we know the create block. Now we have also the create block, but this one provides you with some additional help. For example, instead of typing the probability distribution that you're going to use for interarrival times, it shows you some options. So when you click, you can select the distribution that you want to use. The only thing that is different is originally we set up the time units in when we're setting up our experiments. We say, okay, we are setting up our model in minutes. So all units are in minutes. I need to let the experiments that we are using minutes. That changes here. You can have different time units in the different places in your model. So you can specify the time units inside the blocks. You have the number of entities per arrival, the maximum number of arrivals, and also when the first creation is going to happen. In terms of resources, so you're familiar with the resources element, and then we use C delay release to represent a resource. We still have the C's block that I show you in one of the templates. It is the same thing. You have to add the resource that you want to use. And then instead of having a queue block that we used to have originally, now that queue is going to be showing up here, right? So you're going to have a queue associated with the C's. That's helpful in terms of building animation as well. You'll see that once you add this type of block, there's going to be a line on top of the block that is going to be representing the queue for that particular block. So that's the C's. You also have the delay, which is simple. Again, you have those time units that you can specify inside the block for the delay. And the delay time also gives you some options in terms of if you're using a probability distribution, you can select the probability from there. And then the release is similar to the C's block. So with the difference that you are going to set up after you're completing processing the resource. And as I stated earlier, we can do that combination of C's delay release with a single block now that is called process. As I stated earlier, the C's block has a queue. The process block, if you decide to use it as a combination of C's delay release, which is specified here, it will show up. If you're using the C's, it's going to show up this line here, which is representing the queue. But you have other options here. When you click this down, you'll have options like you can use this process block only as a C's delay, or you can use it only as a delay release, or you can use it as a C's delay release, or you can use it just as a delay. So it has different combinations that you can select from. this block. So it's pretty flexible in that sense. So you can choose what type of combination you want to use. And then based on that, it's going to be changing forms. Like for example, if there's no C's, this Q is going to disappear, and so on. You have the delay type. Also, the probability distributions are going to show up. So if, for example, if you choose to use the triangular, you will see the parameters here at the bottom, and you have to input the parameters. If you choose exponential, for example, this is going to change to just the mean. Other than that, I think for now, that's what's relevant. In terms of assigning attributes, we have the assign and the attributes element. Remember, we use the assign to basically assign those attributes to each one of the entities that cross this block. Now we are going to use the same type of logic. We have an assign block, but this one also has some options here. You can use this to assign attributes, or you can use it to assign variables, or to change the value of a variable. And then depending on what you choose, the name, you have to specify the name and also the value. If you choose to use a variable, you see this is changing now to the variable name. So, and then the new value, in this case, we are using the variable to compute the number of units inside the system or the working process. So after defining my variable, I'm adding 1, assuming this is going to be counting the number of entities that are entering the system. And I can do the same thing towards the end of the simulation, basically before the dispose, and have something like this, num system -1, which is going to decrease the number of entities inside the system by the time they're going to be disposed. And that's what we're going to be doing today in terms of the variable definition. So we'll talk more about that in a minute. Branch block, yes, sir.
So, quick question. Is it more computationally intensive to enumerate each one of the entities coming into the system rather than counting it? Or would it essentially be kind of like the same from running the simulation in a timely manner?
I'm not following.
Is assigning the number for the entity essentially like better? Like,
well, this is trying to do, so I guess if I'm understanding correctly, you're trying to ask whether this is more computationally intensive than just counting.
Correct.
Yeah, so the thing is, this is doing something different. When we are defining this variable, we are trying to keep track of the entities that are inside the system. Okay? So it's not counting how many were completed, but keeping track of how many are inside the system. Like if you were running a airport facility, right? You know, people are going to leave in an airplane. People are going to be leaving once they arrive. So you want to know how many people are inside the airport at any time. This is what this is trying to do. Yes. Awesome. Good, no problem. The sessions, so with Siman or with these elements and blocks, we were using the branch block to set up those decisions. Now we have something called the side block, which is doing the same thing. Now, instead of having a block, we have a diamond representation, like an if type of statement in a flowchart, in which you define if it's a yes or no, right? You have a branch going this way or this way. But we can go into a two-way by chance or two-way by condition option, or we can have n-way by chance, n-way by condition, meaning that you can have as many branches as you need for your process. So if you choose by condition, you're going to be using an attribute to differentiate the branches. If you choose by chance, then it's gonna be based on a probability. Statistics. So those are the statistics that we've been collecting, or those are the three types that we've been collecting so far: the count, the tally, and the time average statistics. We know the difference between them, right? So I'm not gonna talk about this today, but we need to remember that when we are building the output report, when it's a tally, we use the TAVG to get the average across replications. When it's a time average statistic, we are using DAVG to compute the average across replications. We're still gonna do that. The only thing that is gonna be different is where we set up these formulas. In terms of counters, as you know, when you're building with the blocks and the elements, you use these two. Same thing for tallies. When you're using the blocks and elements, we are using the tallies elements and the tally block. You keep track of these the observations that we are getting every time they cross this tally block. We are putting it like in a bucket, like in a bag. So we keep all those together, and then by the end of the simulation, we perform some statistics on those observations. So that's what the tally does. So in terms of how that works with these new templates, well, you only have a record block now, and that gonna take the form of whatever statistic you want to collect, right? So it could be a counter, it could be a tally. So you're gonna have those options, and each record block is gonna be collecting the type of statistic that you select from those options. But again, it's important for you to know what was there before, because now you understand the difference between counters, tallies, and these stats. So you can choose the right one based on your needs. The sets, we can also set up these sets in Arena. Instead of using an element, we're going to be using one of those little spreadsheets to set up those sets. So it's basically the same thing. Instead of going into the elements to define the set name and the members, we're going to go here. We're also defining the name, the type, and also the members, and then we list the members inside this table. So we'll do that also. I don't think we're gonna do that today, but at some point we're gonna be working with those sets. For time persistence statistics, this is what we've been doing. Now we're gonna set up those in the statistic module. So I'm gonna show you how to do that today. But the statistics, all of them are gonna be coded inside this module within the advanced process. Okay, so for the statistics with multiple experiments to generate that output report, we've been using the outputs element block. Now we don't have to use a different or separate entity to do that. We can code everything here in the statistics module to generate this output report. Okay, so again, the slides are there for you to go back and try to, it's like if you forget something, come back, look at I try to connect what we've been doing to what's new. So how everything is connected. So I think the slides are a good source if you at some point get confused. You also have the video, but let's try to work with these new templates. And what I decided to do was just to use one of the previous examples. So you can compare what you did with the new templates and see that you should get the same results, right? So we're going back to this example in which we have two machines. They are different. They have different processing times, even though they are both drills. And then you also have two different part types, A and B. 60% will go, which are the part type A, go to the drill, and then 40%, which are part type B, go to drill number 2. We have interval times, we have the processing times, and we want to run this for 10 experiments and compute the average cycle time for all parts, the average utilization for machine 1 or drill 1, the average number of parts completed, and then the last one is what the variable is going to be used today, is to keep track of the working process or the number of parts inside the system. Okay, so let's open Arena. And let's try to build this model. So the first thing I always do is to save this into my computer. And as I said, you will get to these templates later on. But for example, some of the blocks that we defined today, like the create, the dispose, they are now part of this discrete processing template. We'll get to this later on. But for now, let's do the right-click template panel, attach. So now we are transitioning from the original set of blocks and elements to the second type of blocks and elements. And then next we'll get to the latest one. So let's go inside this old Arena templates and select the basic process. And attach. Also, let's use the advanced process. I think for today, those should be enough. Let's see. Have the basic, the advanced. Yeah, let's keep those two. Okay, so the first thing that you're gonna notice is like I'm not gonna separate this window anymore into experimental frame and model. Because now the experimental frame is gonna be located within the templates and it's gonna be filled out using these modules. Like, look, they look like little tables. Those are the ones that are gonna contain the information from the experimental frame. So the only thing that we're gonna have here is the actual model. Okay, so what is important for you to remember, there's two things happening here. We define our experimental frame and also we build our model. So let's start with defining our create, right? So once you add the create block, you see if you click on it, you will have these options here at the bottom. You can fill out some of the information here, or you can just double click and select the distribution, right? In our case, it's gonna be exponential, 4.4, and that's in minutes. So it is the default, but as you can see here, you have multiple options. You have the random exponential, which is typically what is used to represent interreliable processes. You follow an exponential distributions. Why is that? Because most of the time we are assuming that we have a Poisson process, and we know if we have a plus one process, the interarrival times are always exponential, right? So that's why this is typically what you see as default. But if you're not using an exponential, you can select expression, and then from there you will see all the other distributions are listed. So if you use the triangular, you need to specify the minimum, the mode, and the max. If you use the uniform, you need to specify the minimum and the max. But for now, let's just keep the expo 4.4. And the time units that we're going to use are minutes. Do you need me to turn off the lights, or is that okay? Yes. Okay. Okay, so the statistics, we want the cycle time. So that means that we need to set up an assign block. So let's bring that assign block here. And now we are going to, again here, if you want to define an attribute, you can go here to this module. Let's see what's going to happen. You can name the attribute, and see, you can also provide the initial values. For me, at this point, you can do it from here like you used to do in the experimental frame, or you can go and double click here, add, select if you're going to define a variable or an attribute. In our case, we're going to define an attribute. The attribute name will be the arrival time. And what will be the value? You remember? Tina, that's correct. So, and that's why it's very important for you to start differentiating between attributes and variables, because now when you come to the definition, you have to use the same block, but you need to make sure that you're choosing the right type, right? So you need to know what's an attribute, what's a variable. This is one of the most common errors that I find during the exam, that you don't remember if it is an attribute or a variable, and then you end up defining an attribute as a variable or a variable as an attribute. They are not going to be working the right way if you are not choosing the right type. So arrival time, T now. And the other thing that I want to define today, which is connected to this last one, average number of parts in the system, is that variable that we're going to use to keep track of the entities that are entering the facility. So I'm going to call this num in system. And essentially what I'm going to do with this variable, it is always, every time you start your simulation, variables are going to be initiated with the value of 0. Okay, so that is always the case. So you have to be sure that this is going to be starting at 0. If something arrives, you're going to increment that by 1. In this case, that's what we want to do. So I'm going to call this variable basically what I did. System. And I will increase that value by 1.
So we're not configuring the part type as an attribute?
We are not, I haven't done it yet.
Okay.
Yes. I define the attribute, I define the variable, but you're right. We can also define the part type, right? So that will be another attribute. and we're gonna call this part time. And we are gonna be using build expression, a discrete probability distribution. We know that 60% are part type 1, and the rest are part type B or part type 2. So we have a discrete 0.6112. You have questions? This should be an attribute. Did I choose the attribute? Yes. Okay. So now once you cross this block, you're gonna get assigned the arrival time. You're gonna increase the variable by 1, and you also gotta get assigned the type of part that you are. All that happening within the same assigned block. Something that I don't necessarily like about Arena is like you did all that thing, all those definitions here, but when you close, it's not showing you anything, right? So you have to remember that the code is behind it. The only thing you can do is if you click on it, you get to show, it shows you that this assign has 3 rows. And you can click on that row and it's gonna show you the information that is inside the block. Variable, attribute name, and the value. Okay, so now we have the information about the part type, so we can decide, right? So I'm gonna bring a decide block here. Which parts are gonna go to drill 1? Which parts are gonna go to drill 2? So I'm going to select a two-way by condition. So once that's selected, you get some new items in this window. Okay, so you're gonna select, what are you gonna be using? Well, I'm gonna be using an attribute. Which attribute? You define the attribute already. So typically, whatever you define as an attribute is gonna be listed at the end of the list. But there's some other information that is generated by the software. Like create time, hold cost rate, jobs. Those are other attributes that you can also play with. Again, those are not generated by the user. Those are software generated. Though for now, we are gonna be working with the ones that we are defining. And if it is equal to 1, you want that to go through one of the branches. So when you do that, you see here, let me increase the size. So what you're gonna see here is if the condition is true, you go through this output. If the condition is false, you go through this output. So in our case, since we only have 2 part types, we can deal with this only condition. Okay, so if it is equal to 1, you're gonna go through this branch. If it is not equal to 1, you go through false. Okay, so next we need to define the logic for the drills. So for that, we're gonna use a process. So I'm gonna pull 2 of those, one for drill 1 and one for drill 2. Let's double click on the first one. And this is what I was telling you earlier. The logic action has multiple options. You can use this as a delay. You can use this as a delay, a sys delay release, or delay release. So depending, as you saw in one of our labs, the one with the operators, you were using different combinations. So this gives you the options that you might need for those type of scenarios. In this particular exercise, we are just going to use the sys delay release. Priority, in the case in which you have an entity that can choose between the two resources, you can identify which one will have a higher priority, which resource do you want to be selected first. As right now, that's not something that we will need. But we need to name the resource. So I'm going to call this drill 1. The units to seize, how many units do you need to seize every time? It's just 1. And then what is the distribution that we are using? Triangular 3.2, 4.2, 5.2. So 3.2, 4.2, 5.2.
Hours?
Good one. Yeah, I didn't see that. So this is in minutes. Thank you. And you notice that since we are adding the C's, you see that queue, right? So you can move the process queue. Like if you're doing animation, you can move that. I can show you that later on, but the queue is going to show up. It's not showing up now because right now this is just a delay. But if you do the sys delay release, we can do the same thing, define the name, which is drill 2. And then this is also a triangular with 3, 4, 5. Yes.
So, how can we define the capacity of the queues?
So the question is, like, if you have only 4 spaces in your queue, that's a good question. So when you close this, let's say you define your resource and you click on that queue, you should get some, let's see, cancel. Where's the queue? Okay. When you go here into your basic process, there's one module that is associated with your queue. That's not telling me the capacity of the queue. I assume that this was where you're going to be having that information. That's not the case. And if we click here, it's not the case either. Yeah, originally you will go here and it will tell you not only the type, but also the capacity. Unless this is not, this is the capacity of the resource for the identical machines. You know what? And that's why I teach you guys to use the alt templates, because some of the functionality is gone. One of those is stating the capacity of the queue. So, and then I don't know if I mentioned this, but you can combine the alt blocks with the new ones, right? So if you, in your case, if you wanted to define the capacity of the queue, then you're gonna have to rely on the logic from the alt blocks. And I'm glad that you asked that question, because that's exactly the point that I was trying to make from the beginning. Like, as you move towards simplification, you're losing some of the flexibility that you have to build some of your blocks. Good. So yeah, so that's not the case here, but if you end up getting some type of queue capacity limitation, you had to use those old blocks.
So we can use separate queues for those two process, right? Queue block and
So
if we need to define the capacity of the queue.
yes, so in that case, I will define the logic for the resource, all of it, using the old template.
Yes.
Okay. Or you can avoid the use of the Cs, use the delay release, but use the QCs from the old templates. Okay. Good question. So let's connect this to this. Okay. So from here, we are done with the setup of the resources. So the last thing will be to collect the statistics, and we had cycle time, utilization, parts completed, and average number of parts in the system. So we need to collect the cycle time, and we need to use a counter as well. So I'm gonna pull some record. I think we can do both of them with the same block. We'll see. So if I come here, first I want to count, right? So this is parts completed. So nothing difficult here. The only thing that you have to do is to put the name of the counter, right? You're going to increase that by 1. So that's the counter. And then using the same block, I can define time intervals. So this is for the cycle time. So when you select the time interval, it's going to ask you what attribute name you're going to use to look at the difference between the current simulation and the arrival time. And then we can name the tally. So this is going to be cycle time. Got it? Okay. And the last piece is to use another assignment. Where's the assignment? To decrease that variable that you have defined numbing system. Because you're about to dispose those entities. So now what I want to do when they arrive is to increase this by 1, but once they leave the system, I want to decrease that. That will tell me exactly how many entities are inside the facility at any time. And I'm using a variable for that. So at the beginning is 0. As you start entering, it goes 1, 2, 3, and then some of them start leaving, goes back to 2, goes back to 3, go back to 5, 2, and it's going to be changing. So this is going to be changing throughout the simulation. Okay, so I have that variable. And then after that, we can just dispose. So there's more work that needs to happen, but at this point, I want to save and also want to check my model to see if you have any errors at this point. Errors? Nope. Awesome. So let's work with the statistics before we set up our experimental length and so on. So as I said, we are going to be using, instead of the output, we're going to be using this statistic module. So I'm going to click there, and it's going to show up empty. So we're going to start adding information here. The first thing that I want to define is a statistic for the utilization, right? So this is going to be time persistent. And you remember the expression NR, the name of the resource, which is drill one. And if you remember, for this time persistence statistic, it's important for us to name. So the default name is statistic one. I like to change that to something like drill utilization. The second time persistence statistic that I'm going to keep track is that that we define for the parts inside the system, or num in system, right? This is a variable that is going to be changing values, and it's going to depend on the time of the day, right? To define the actual value of this. So for this variable, I'm only listing the name of the variable. There's nothing have to be before that. For the variable, we just use the name of the variable. And I'm gonna call this I don't know, parts in system. So those are the two time persistence statistics. Now we define the output report. So I'm gonna add another row, and now I'm gonna start dealing with the 4 outputs that I'm using for my report. So let's start with the first one, cycle time. Right, so I have a tally here that is called cycle time. That is the tally that I'm going to use for my output. So this is the AVG cycle time. And the report label will be average cycle time. So that's the first one. Sorry. The second one is the average utilization of machine one. Right, so this is gonna be my second output. I'm gonna use DAVG because it's a time persistence statistic. And remember, for these stats, we use the name of the report label, right? So there's gonna be drill utilization. And this is AVG utilization. So every time I build an output item, or an item for the output report, I'm putting average in the report label because it's the average across replications. So in that way, I remember. I know this is the average across replications. So the average cycle time means average across replications. Average utilization is average across replications. The next output, average number of parts completed. So this is an output, and this is for my counter. So for counters, I use NC, the name of the counters. What was the name of the counter? Parts completed? And then this is average parts complete. Need to make sure that that's the name. So yes, parts completed. That's correct. Okay, so I have three, missing one. This is the last one. The working process. So to output. And it's gonna be also TAVG, parts in system. And these are AVG parts in system or working process. Okay, so I'm gonna save and check the model again. Let me know if you have any errors. Nope. Good. So let's set up our experiment. See how many replications? 10. Now I'm gonna be running this for how long? Let's run it for 8 hours. And the base time units are minutes. Lie. Project parameters. Lab 4. It is. And I'm going to uncheck all this. And then for the report, we're going to choose the Siman. And then click apply. So those are 3 things that I have to do. Set up my experiment for 8 hours. Change the base time units to minutes and use the number of replications equal to 10. For project parameters, I uncheck everything. So the report shows only the values that I'm interested in. And then for the reports, the Siman summary report. Yes. So 10, 8, 24, and minutes.
So, what did you put in the dispose block?
Where?
The dispose block, yes.
Dispose, there's nothing there. It's,
nothing.
yeah. Yeah, that's like I can run it. And you see there's no animation going on. That will delay the processing. So I want to click here, batch run, no animation. And I can run it quickly. And this is what I'm observing. Average number of parts in system, 1.39. Average parts completed, 111.8. Average cycle time, 5.93 minutes. Average utilization, 0.58. You got those numbers? Any questions? we're getting close to the end of the session, so I'm gonna stop here. Again, if you have questions, make sure that you look into the assignment and come with questions on Wednesday. I can address those questions this week, so you are in good shape for submitting on Monday. And then we're also gonna discuss the project. I'm not gonna have office hours. I have to go to JCK now. As I mentioned at the beginning of the